I want to use implicit differentiation to find dy over dx for x cubed plus y cubed equals 4. First, I'm going to take the derivative of x cubed. With respect to x, it's just 3x squared. But when I take the derivative of y cubed, I'm going to use a power rule, but then I want to multiply by the derivative of y with respect to x. And this is the chain rule part. And that's equal to 0, because the derivative of 4 is just 0. I'm going to move the 3x squared to the other side. I have 3y squared times dy over dx is equal to negative 3x squared. I'm going to divide both sides by 3y squared. I'm going to get negative 3x squared over 3y squared, which is negative x squared over y squared. And that's my derivative. Next, we're going to be looking at the quantity x minus y squared equals x plus y minus 1. I'm going to use implicit differentiation and find the derivative with respect to x. So first, on the left here, we're going to be using the chain rule. So we're going to be bringing down the exponent, subtracting by 1, and then multiplying by the derivative of the inside. And on the right, the derivative of x is just 1. The derivative of y with respect to x is dy over dx. And the derivative of negative 1 is just 0. Okay, so I have 2 times the quantity x minus y. The derivative of x is just 1. And then derivative of y with respect to x is dy over dx. And that's equal to 1 plus dy over dx. Okay. This one I'm going to FOIL. So I have 2. And I'm going to FOIL out the x minus y with the 1 minus dy over dx. So I get x minus x times dy over dx minus y plus y times dy over dx is equal to 1 plus dy over dx. I'm going to distribute the 2. So I'm going to have 2x minus 2x dy over dx minus 2y plus 2y dy over dx. And that's equal to 1 plus dy over dx. Okay, here we have 3 terms that involve dy over dx. 2 of them are on the left, so we'll just move this one over. The rest, so 2x, negative 2y, will all go to the right. Okay, so I'm going to have negative dy over dx, and I have negative 2x dy over dx, and positive 2y dy over dx is equal to negative 2x plus 2y plus 1. Yeah, just plus 1. Okay. Let's pull out a dy over dx. I'm left with negative 1 minus 2x plus 2y is equal to negative 2x plus 2y plus 1. And I'm going to divide both sides by negative 1 minus 2x plus 2y. And I'm going to change the order. So notice here that the x is first, so I'm going to think of that as negative 2x. The y is next, so that's plus 2y. And then 1 is at the end, so it would be minus 1. So I'm going to divide by this instead, which is equivalent. So I'm going to have negative 2x plus 2y plus 1 over negative 2x plus 2y minus 1. Okay. So the only difference between the numerator and the denominator is the sign for 1. On the top here it's plus 1, The bottom, it's minus 1. So unfortunately, I cannot simplify this any further. So we stop here, and that is our derivative. Let's look at y equals x squared times y cubed plus x cubed times y squared. We're still going to be taking the derivative with respect to x. So the derivative of y will be dy over dx. For x squared and y cubed, we have to use a product rule. So I'm taking the derivative of x squared times y cubed plus the derivative of y cubed. We're going to bring down the exponent, subtract 1, and then multiply it by the derivative of y with respect to x times x squared plus, and then we have to apply the product rule again for x cubed times y squared. So that will be the derivative of x cubed is 3x squared times y squared plus the derivative of y squared is just 2y dy over dx, and then times x cubed. I'm interested in dy over dx, so I'm going to look at the terms that have the dy over dx, and those will just move to the left. So we'll move it by the dy over dx. So we have dy over dx minus 3x squared y squared. So I'm going to multiply these out, x squared y squared, dy over dx. And I'm going to multiply 2y with x cubed to get 2x cubed y times dy over dx. Okay, what's left? Equals 2x y cubed plus 3x squared y squared. The next step, we're going to be factoring out a dy over dx. Okay, so I have 1 minus 3x squared y squared minus 2x cubed y. Okay, and that's going to equal 2x y cubed plus 3x squared y squared. And last step here, we're going to divide by 1 minus 3x squared y squared minus 2x cubed y. And in this case, we cannot simplify any further. So we will leave it as is. So that is our derivative. Okay. Next one, we have an equation that involves e. So it's just e to the xy equals e to the 4x minus e to the 5y. So we're going to take the derivative with respect to x. So the derivative of e to the xy is itself times the derivative of the exponent. The derivative of e to the 4x is itself times the derivative of the exponent is 4. And e to the 5y is itself times the derivative of the exponent, which is 5 times dy over dx. Okay, so next we're going to multiply by the derivative of xy. So this one we have to use a product rule. The derivative of x is 1 times y plus the derivative of y with respect to x is dy over dx times x. Okay, and that's going to be 4e to the 4x minus 5e to the 5y times dy over dx. So I have two terms that have a dy over dx, but first I want to distribute out the e to the xy. So I get y e to the xy plus x e to the xy times dy over dx, and that's equal to 4e to the 4x minus 5e to the 5y times dy over dx. I have the option of working or isolating the dy over dx is on the left or the right. In this case, it doesn't really matter, so I'm going to move this over, and the y to the xy will go over here. So if I do that, I have x times e to the xy dy over dx, and then instead of minus, it's going to be plus 5 times e to the 5y times dy over dx. And then we have 4e to the 4x minus y times e to the xy. I can finally pull out a dy over dx. I have x times e to the xy plus 5 times e to the 5y is equal to 4 e to the 4x minus y times e to the xy. Finally, I want to solve for dy over dx, so I'm going to divide both sides by x e to the xy plus 5e to the 5y. And that is my derivative.